So welcome to my Work Solutions walkthrough, whatever you want to call it, for the AQA Higher GCSE Maths. It's paper 2, so calcs allowed from the summer of 2024. Question 1, not going to waste any time on this. Get them all learned, folks. A is a segment and B is a sector. Get all the parts of a circle learned, 1 or 2 marks, always shows the face. Now to some proper maths. Number 2. You've got a 12% reduction from the original. So remind yourself, when you're in this situation, you don't know the starting amount, but you can create your multiplier. 12% reduction means take 12 pence away from a pound. That will give you the 2.2 million. And that's why this is reverse percentages. You take the final amount, you divide by your multiplier, and that gives you your original amount. In this case, 2.5 million. But the extra bit on top, once it in standard form, millions means power of 6. And that is where we... Oh, that's rubbish. And that arrow is supposed to be an arrow, that. 2.5 is where you want your decimal point. On we go. Number 3. So a chef has this daft little formula. D equals K divided by B. So number of desserts. B is blueberries on each dessert. So ultimately, this should refer to how many blueberries they have. And that is the number of blueberries in the tub. That's how many they've got. Complete the table. So as you can see, they've done one for you. You can notice, I hope, that 2 lots of 120 is 240. And so one way of doing it is filling in that 6 times 40 gives you the same, and 8 times 30 gives you the same. But that's not a massive shortcut to just using that formula. Number 4. You can use the blank spinner. You don't have to. There's your key statement. Probability of an even number is equal to the probability of a 7. So there must be as many 7s as there are even numbers. There must be as many 7s as there are 6s and 8s. Each number appears once. So that has to be a starting point. But at the moment, the probability of an even is, as you can see, 2 of the slices, 2 of the portions. Probability of a 7 is 1 of the portions. So we need another 7. Question is, what goes in the last? Well, we don't want another 7. We don't want another even number. Those 3 options destroy what you've been told here. So it has to be a 5. So work out the probability of a 5, 2 slices out of 6. Part B, you can phrase it however you want. Any little sentence that says they should add up to 1 and not 1.1, because they do and they shouldn't. Number 5, coordinates of C and D. So C is the easy bit. It's the intercept. It's the bit on the end. D, you either do a bit of thinking, but to show you where it comes from, the x-axis is y equals 0. So for y to equal 0, 2x would need to equal 6. They would need to cancel out. And so it's got to be a 3. 5b, well, the y-intercept, that's the easy part. The x-coordinate of the turning point, you either know it or you don't. And if you don't, learn from this. The turning point T is also the vertex. This is also the line of symmetry. And why is that important? It's halfway between the -2 and the 8. So add them together, 6, and halve it, and you're done. Number 6, I would just say, people, you've got a calculator. Get it into your calculator. Mine did it all for me. It's probably why it's only worth 1 mark. 6.4 times 10 to the -14. On we go. Number 7. Which work out the best estimate. The best estimate is always the most trials. Again, any short, sweet sentence that says 52 out of 100 is the best. 200. My mistake. Because 200 trials is better than 50, 100 and 150. On we go. Number 8. Yeah, a little bit of cheating because me and technology don't go well together. You can draw any triangle you want, but I've gone for the biggest. If you count it, each small square is worth 5. I get the height to be 90. That's 120 up there and 30 here. And if you count the width, that's dead easy. It's 5. So you've got distance travelled 90. You've got time 5. And as you'll know, speed is distance over time, and 90 divided by 5 gives you 18 meters per second. Number 9, it's the intersection, it's the crossover, it's the bit in the middle. Move on. Wordy number 10. At the end of the day, when it says show, do, whatever, that's your capital. 90,000 is your starting point. To increase by 3%, your multiplier, you add 3 pence onto your pound. And for 8%, add 8 pence onto your pound. On your calc, that should give you 100,116. But don't forget to answer the question. It says, is it more than 100,000? Needs a yes to get full marks. Number 11. There's 2 types of scale drawing. There's those that convert units, as in they'll say centimetres equals kilometres. There's those without units. In other words, the units are like for like. So this is the latter. It's like for like. So to go from scale to real life, it's times by 20,000. So 15 times 20,000 will tell you that the 2 churches are 300,000. That's 1 too many. They are 300,000 centimetres apart. I'm not a fan of going straight to kilometres. Divide by 100 gets you to metres. 3,000 metres. Divide by 1,000. And always ask yourself, does 3 kilometres seem reasonable for a distance between 2 places on the map? Absolutely. Number 12. Not a single angle is involved. So there's 2 angles, they're gone. Right angle, gone. Angle, got to be side, side, side. Number 13, we like these questions, particularly when they've set them all out for you. So to estimate the mean, you do the midpoints. What a clue. So 7.2, 7.6, and 8.0. You might have a teacher who insists that number of jumps is F, midpoint is X, and your final column is F times X. It's fine if they insist on that. They're just preparing you for some A-level notation, really. Never does you any harm. At the end of the day, when you add up, you sigma it, you sum it. When you sum your fx's, you get 300.8. And so it needs dividing by the number of jumps, 40. And it says give your answer a decimal. Well, 7.52. 7.5 is fine, but it's not the biggest deal in the world. Number 14. Part A. Assume it's in that form. So assume it's in the y equals x squared, but moved up or down a bit. Well, anyway, if it goes through that point, it tells you that when x is 3, y is 15. Sub them in. Y is 15. When x is 3, we know that c is 6. So it's this one. It's the x squared graph moved up 6 units. But we need a bit more than that. We want to know the y coordinate when x equals 7. Well, y equals the x coordinate squared plus the c, which we found, 49 plus 6 is 55. Now, B's a weird one. Basically, it is impossible to tell. And why is that? Because the idea is it might go through 315, but who's to say 315 might be there? Who's to say whether the gradient is positive or negative? Could do a lot of things. So it's not possible to tell. Number 15, calculators at the ready. 30 minutes. How many seconds is that? Times it by 60. If it does 10.9 per second, times it by 10.9, and that will tell you that in 30 minutes, 19,620 kilograms of concrete is poured. Divided by 1,000, and there we go. Is more than 20 tons of concrete poured? It's not. It's close, but it's not. Number 16, I've obviously cheated again, me and technology. All you need to know is what a box and whiskers plot looks like. Well, I'm sure you've seen one. There's only one bit where you have to do a bit of working out, because shortest length, you're told. Longest length, you are told. Upper quartile, it's given. Median is given. It just doesn't give you the lower quartile. So you need to do 7 minus 3 so you put your lower quartile line in at 4 and on you go. Number 17. So it's starting to get a bit trickier on this question, if I'm honest, but you stick to the basics. Don't worry about what comes here. Look at that line. Ask yourself what you know. You know that angles on a straight line, hey, they go 180. Of course they do. Not only an idiot would write 10. So if you add these together, you get 180. Well, if we add the numbers together, we get negative 44 plus 15, so we get negative 29. And if we get a quarter added to 2/3, we can get that on our calculator. Whoops. That will give us 11/12. We add 29 to both sides, and I think the best way to work out x, 209 into your calculator, multiply by 12, divide by 11. You've got your value of x to be 228, but you haven't finished. Get this first angle, by quartering your 228. So divide it by 4 and add 15. You should get 72 for the little angle, meaning the big angle is 108. It doesn't ask you to cancel it down, but 72 to 108 is fine. But 2 to 3 is where it could end up, or anything in between. Number 18, they've obviously given you a little prod saying, here's some space, you might want to draw a diagram. Well, there we go. The diagonal is 23.7 long, and the angle is 52 degrees, and that's the angle made with the side. So it's not that. So don't use that. So once you've drawn the rectangle, it is a case of you don't necessarily need a full rectangle. You know that this is 23.7, and when I say this, I mean the hypotenuse. The angle is 52, and the side length is x. Okay, the diagonal makes an angle of 52 degrees with a side of length x centimetres. We've got to find the adjacent. We don't want the opposite. It's a question. And we want the adjacent. The adjacent is cos of our angle times by the hypotenuse. If you've got a calculator, which is a smart aleck, and opens up brackets for you, make sure you close it. Make sure you get 14.6. Mark scheme allows anything from 14.59 to 14.6 inclusive. Number 19, it's one of them that looks quite bad, but as long as you trust the process and just get on with it, if all of it simplifies, load is going to disappear. And the sooner you do things, the sooner it's going to look simpler each step. Let's remove the brackets. That first loop will give us 12x squared. Next loop will give us 8x. Here, that will give us minus 12x squared, and already the simplifying process begins. Take care with the next loop. It's a minus times a minus. 2 times 5 is 10, and it's x squared divided by x, so it cancels. Finally, that loop gives us minus 18x, and that one, again, take care, minus 6 times 7 is minus 42, and the x's cancel. Look what happens when you line your x's up. They basically all disappear. And that's it. That's all it wanted. That's all the mark scheme wants to see. Number 19, definitely one of the hardest type of factorisings, but it practices your AC method. Get on with it. You've got a calculator. The numbers aren't friendly. So what? Get on with it. A times C is minus 280. Always create some room. Split your page and say which two numbers multiply together to make minus 280 but add together to make minus 18. I've got to admit, I think they're a little bit more obvious than you might think, because yes, it's minus 28 and positive 10. That's the split in terms of the numbers. Don't forget, you've got to have the x's and then factorise each half. You are hoping that the brackets are repeated there and there. So let's see. What do these have in common? A 2 and an x, and it will need a 4x, so they multiply to give 8x squared, and it will need a 5 to expand to give 10x. Let's hope the same happens over here. What do these have in common? 7 times table and a minus. Minus 7 times what? Well, that's 4x. And minus 7 times positive 5 is minus 35. And then you know you've got it right. It double checks itself. So the leftovers form one bracket and the repeats form the second bracket. On we go. Number 20, bit of a strange one. Ultimately, it's a quadratic formula question, so do flick back to formula pages and all that. But let's form it first. Your job, it's x squared and it's going to be more x squareds. Your job is to make it equal to 0. Use the quadratic formula or complete the square if you're that way inclined. But first of all, get it all levelled off. Multiply both sides by x plus 3. You can expand the top now or later, entirely up to you. And now we can expand the left and the right. Left hand side gives us x squared minus, depending on what order, and you might need to do grid, it's entirely up to you, minus 27 minus 9x plus 3x, we'll simplify in a bit, 2 times 6, 2 times minus x squared. And now we get it equal to 0. Keep your x squared positive. So I'm going to add 2x squared to both sides, simplifying the x's. And we've got a minus 27. We've got to take away 12. Oh look, 3 times table. We divide everything by 3, including the 0. Then quadratic formula. It's minus b, a is 1, b is minus 2, c is minus 13. So it's minus b plus or minus b squared is 4, and it's minus 4 times c, so it's going to end up as a positive, and it ends up being 52 all over 2a. Start looking at your answer. We're nearly there. Basically, the d is 2. The e is the bit in the radical. It's 4 plus 52. And the f is the denominator on the bottom. That's a 2. You don't need to simplify it or take any further. That's all it wanted. Don't do more work than you need to. Number 21, it has been said that if you organise a problem, you are halfway to solving it. And this waffly one is definitely one where you need to do that. Northeast, southwest. Get it organised. A quarter in the north stand. 3/10 in the east. Number of south to, so they are 2/9, but don't forget, that's not a fraction of the whole. That's compared to each other. So you can't go putting 7/9 yet, because it's 7/9 of something else. So before we do that, let's look at the north and the east stand. On my calc, added together, they make 11/20 of the crowd. So these two make up 9/20. Whoops. So the west stand is 9/20 of 7/9 of an unknown number of people, and that's worth 4,480. Grab your calculators. 4,480 divided by 7/9 divided by 9/20 gives you 12,000 800 people for the attendance. Number 22. I'm not going to write this out in full. That's done on my work solutions on my PDF. Go onto the website, have a look at those. The fact is, use the ANS button on your calc. If you're not sure how, well, for the first term, stick in 1. So it's basically 5 minus 1 over 1. You don't need your ANS button yet. Your next one, 5 minus 1 over 4. So 5 minus a quarter is 4 3/4. Now, if you leave 4.75 in your calculator display, you can then type in 5 minus 1 over ANS, and you can repeatedly hit the equal sign. To make sure you're doing it correctly, you should get 91 over 19, which is basically 4.78-ish. Then it spits out 436 over 91, which is 4.7912-ish. And it goes again. Your next iteration is 2089 over 436. And guess what? It's basically the same to 4 decimal places. Well, it only wants 4 significant figures, which in this case is 3 decimal places, so you can stop right there. Don't carry on pressing equals, you're wasting your time. Number 23, couple of ways of doing this one. To show that things are on a straight line, you can show that they are parallel and they have a common starting point. So you have a choice. You can either work out the vector d to e, followed by e to f, and there'll be a multiple of each other. You can times by 1 and so on. Or you can do de and df, and a similar approach. Either one, both will work. I've gone for the latter. So how do I get from d to e? I go with this vector. Whoops. And I go with that vector, which simplifies to 8b and minus 8a. It's been a long day. So 8a minus 4b. But I'll take a 4 out, because chances are, if I went for EF or DF, it's going to involve 2a minus b and some number or fraction, whatever, in front of it. Let's do DF. Same again. You go with that vector, and you get 10a minus 5b. Take a 5 out, and there's 2a minus b. And now you can summarize. Always nice to have a sentence to bring it together. I've gone for that they have the same vector components and the same starting point. Hence, that would make them a straight line. Essentially, they start at D and they are parallel. And if you've done E to F, you'll get what, a fifth and 4/5 and so on. Same process. Just make the argument that they have the same vector component. They are multiples of each other, or any words to that effect. Number 24, I'd say quite a strange one. It's essentially hidden proportion. Hidden because you have to use that coordinate when time is 6, when x is 6, y is 21. Get that subbed in. 21 equals k over 6. So k times both sides by 6 is 126. Work out the value of y when x is 6. So y is 126, that's our k, divided by x, and you should get 10.5, or the fractional equivalent. But part B is a bit of a weirdo. Have a read, soak it in for a sec. Obviously it's a tick box, so make sure you get the right answer, but they've given you plenty of room, so it's not just a quick one, this. You're into the penultimate question. It's not as straightforward as you might want it to be. The fact is, you've got a formula. Take your 21 and you've got a third of a 6x. So it's a third to the power of 1/6 of x. Well, x is 6. 1/6 of 6 means power of 1. Well, you're there, aren't you? Basically, A is 63. As you do with proportion questions, rewrite your formula, but you now know the constant A. How does this affect the value of y when x is 12? Sub it in. 1/6 of 12 is 2, and your calculator will give you the answer of 7, which, if you refer back, is less than your answer to part A. Hope that made sense. Strange on that one. As is this, your final question. 3D trig, or 3D whatever you want to call it, looks like 3D trig, but it's actually 3D volume. You've got the ratio of the edges. Ask yourself, how do we find the volume? A half of the base, which is B, which is 4, times the height, which is A, which is 3, multiplied by D, which is 12. And that will give you 72 somethings, which are 1, 1, 2, 5. Because those somethings are a proportion. It's going to work, and we can work that out. The fact is, divide both sides by 72, you get 1125 over 72. But here's the deal. That is your multiplier in terms of volume. In terms of that's a terrible 2. In terms of 3 dimensions. We are going to want, because these are edges, these are linear. They are linear scale factor. We don't want the volume scale factor. We want the linear multiplier. We need to cube root it. So it all cancels down. It looks like it might be messy. It's not. Your multiplier is 5 over 2. And now don't celebrate too soon, because work out the total length of all the edges. You've got a triangle at the front. That's A plus B plus C. There's a triangle at the back. So that's doubled. You've got a D, a D, and a D. So the D, which is 12, needs to be trebled. But that is working in the ratio. All that turns out to give you a nice 60, but that's not including the linear scale factor, the linear multiplier. You've got to times them, and you get a nice answer. Just a horrible question, really. Not the friendliest. It's a strange one, that one, but it is what it is. It was linking your volume scale factor to your linear scale factor by cube rooting it and crossing your fingers that it all worked out nicely. Anyway, hope that helped. See you on the next one.